These are the 3 most missed questions from the functions GVC test in this class. Number 11 was the most missed, then number 2, then number 4. We're going to go through each one and you can add them to your notes. On number 11, we have to choose the graph that best represents the situation. So on part A, Jane is hiking towards her campsite and we have to keep track of the distance she is away. As she gets closer to her campsite, the distance is going to decrease. Then she sees a snake and runs farther away from camp, so her distance will increase as she gets farther away. When she sits down to rest, the distance is going to stay constant because she's not getting any closer or any farther away from camp. So we want to choose the graph that shows her decreasing the distance, then increasing, and then staying constant. On part B, Ravi's jogging for a workout. His speed, as he gets faster and faster, is going to increase. When he reaches the speed and stays the same pace for several minutes, his speed is going to be constant or the same. And when he slows down, his speed is going to decrease to 0 when he stops. So we're going to look for a graph that is first increasing, then staying constant, and then decreasing down to 0. For problem number 2, we're going to look at each graph and see whether or not that relation is a function. Remember, a function gives one output for each input. The input is x, so we're going to check values for x and make sure there's only one point on that value. For example, if we look at where x is -2, there's only one point on that line. Then we would check the next number. When x is 0, there's only one point. When x is 2, there's only one point. When x is 3, there's only one point. And when x is 5, there's only one point. Since there's only one point for each input or x value, this is a function. On the next one, when we check an x value, since it has 2 different points where it touches that relation, that means there are 2 outputs, so this is not a function. It's called the vertical line test. Any time that we draw a straight up and down line, if it only touches one place at a time, then it's a function. But if it touches more than once, it's not. In the bottom left relation, when we check these, there is one point where it looks like it's touching on the top and the bottom. It is touching on the top, but since the bottom point is empty, that means it does not count. So that does not count as touching twice. It's only touching in the top and not the bottom. This is an inequality. Like when we say x is greater than 2, it means it can be anything bigger 2, but 2 is not included since it's not bigger than itself. If we check the rest of that, nowhere else does it touch more than once, so that's a function. The middle one touches on the top and the bottom, so it's not a function. And the last one has a point where we have 2 points on the same x value. It touches top and bottom, so that's not a function either. On number 4, we want to find the domain and the range for the relation, which means we have to find all of the x values and all of the y values. Remember, domain is x and range is y. To find those numbers, we have to find the points, the ordered pairs for each dot on the graph. So we're going to look at each point and find those 2 numbers for x and for y that are the coordinates for where that point is. Then, the domain is all of the x values for those points. Remember, x is always the first number. And the range is all of the y values, which would be all of the second numbers in each ordered pair.